Hello guys, welcome back. Last time we introduced the normal distribution. We also looked at how to find the area to the right of a z-score, to the left of a z-score, and between two z-scores. Today we're going to learn how to find the z-scores given a particular area in the curve. We're going to illustrate that using these examples. We want to find the z-score that has an area of 0.26, 0.56, and 0.85. And to do that, we're going to use the function in TI-84 plus called invnorm. Now remember the last time we used a normal CDF to find the area on the curve. So today we're going to use invnorm. All we need to know is the area, the mean, and the standard deviation. So let's go on and find the z-scores that correspond to these areas. Now if you look at this first one, area of 0.26, you can see that it is less than 0.5, which tells us that it's going to be to the left of the mean. So this is what is going on here. If we have a normal curve like this, you have the mean right here in the middle, and then you will know, I already said that the area to the left of the mean is 50%. And remember that we are moving from, when we are computing the area, we're starting from the left. So an area of 0.26 is going to be somewhere here, area of 0.26. So what we are trying to do is to find the z-score that corresponds to this area right here. Okay, so to do that, we're going to use invnorm. So we'll go to our calculator and turn it on. Okay, we'll go to second verse. Well, that's where we have the distributions. Number 3 is the invnorm. So we'll select number 3, and the area is 0.26. 0.26. Okay, and then the mean is 0 and the standard deviation is 1. Because we are looking for the z-score, the mean has to be 0 and the standard deviation is equal to 1. So we'll go down and we're going to paste, and you can see that the z-score is negative 0.643. Remember that because the area is on the left of the mean, the z-score has to be negative. Okay, so the same thing we are going to do with finding the z-score of the area of 0.56. We do go back to second verse and select number 3 again, and we're going to change the area to 0.56. Everything else remains the same, so we're going to paste and enter. So we have 0.150. Again, you can see that 0.56 is bigger than 0.5, so it has to be on the right of the mean, to the right of the mean, which will give us a positive z-score. The same thing is going to happen for 0.85. It's greater than 0.5, which means that the z-score will be to the right of the mean, which means we'll have a positive z-value. Okay, moving on, we are going to find z alpha. Sometimes we'll just be asked to find z alpha. Now alpha represents the area to the right of the z-score. So for instance, if we have z, let's write it right here, z 0.15. What it's simply saying is that there is a curve, so this is the mean. Then there is an alpha here of 0.15. Okay, so right here is 0.15, and to the left should be what? The area to the left should be 0.85. You subtract 0.15 from 1, 0.85. Okay, so we are looking for this z-score right here. Okay, and to find the z-score, we're going to do what we did before, except that we're going to use 0.85 this time, because it is to the area to the left of the z-score, and that is what we always use, the area to the left of the z-score. Okay, So we are going to use envnum 0.85, 0, 1 to find that z-score. So we do the same thing second vars number 3, and this is 0.85. Okay, mean is 0, standard deviation is 1. So we're going to compute that. So we have 1.036. So z alpha of 0.15 is the same thing as 1.036. Okay, so all we need to do is to use envnum, subtract this from 1. That will be the area we use, and then of course mean is 0 and standard deviation is 1. Okay, all right, so moving on, we have applications. We just want to see how we can interpret some z-scores. Now remember, general z-score is telling us how many standard deviations a particular score is from the mean. Okay, so given a random, we have a mean of 58 right here, and standard deviation of 3.6. So we want to interpret or see what 63 inches of height means. Okay, so again, remember that the z-score formula, as I wrote before, is given right here as x, or the score, the raw score minus the mean, divided by the standard deviation. Okay, so this is what we have here. So whatever value you get after plugging in those values will tell you how many standard deviations the number is more or less than the mean. So in this particular case, we just plug in. You have 63 as our x. That's what it is. We're looking at the a. And then we have 58 as the mean, divided by 3.6. You get a value of z-score of 1.39. So what does it mean? It means that this height of 63 is 1.39 standard deviations above the mean. If we get a negative, then it means below the mean. Now for the second one, B, there's a height of 54.4. We're going to do this right here. 54.4 minus 58, enter, divided by 3.6. So we have a negative 1. So the z-score is negative 1. What does it mean? It means that the height of 54.4 is 1 SD standard deviation below the mean. Okay, 1 standard deviation below the mean. Okay, the same thing is going to happen for C. Let me use parentheses this time. I'm going to have 1850 minus 1509 divided by 312. This is what we get. Oh, I didn't close the parentheses. So 1850 minus 1509, let's enter, divided by 312. So that's what I have, 1.09. Okay, 1.09. So what it means is that this number 1850 is 1.09 standard deviations above the mean of 1509. Okay, all right, let's look at our last thing for this lecture, and that is going to be how to find the raw score if we know the mean, the standard deviation, and the z-score. So this is a simple example. There is a mean of 190 pounds and standard deviation of 5.5. So if we are given the z-scores of 1, -0.5, and 2, we want to find the actual weight. Okay, so if we have the mean of 190, the standard deviation is 5.5, and the z-score is 1, so we just plug it in. Okay, this is the formula: mean plus standard deviation times z-score. So when we do that for the very first case, this is what we have. So the raw score is 195.5. Okay, now for the second one, the z-score is negative 0.5. Let's do that using the calculator. So we're going to have the mean is 190, 190 plus is right here. Then we have the standard deviation is 5.5. Then parentheses, the z-score is negative 0.5. Okay, so we enter. So what we get here is 187.25. That's what we have. Okay, so that is how we find the raw score if we know the mean, the standard deviation, and the z-score. Okay, so you can now work on the rest of these problems. Okay, so next time we are going to be looking at the sampling distribution. Till then, thank you so much. Bye bye.